Hey guys, today we're going to have a look at sector areas and basically what a sector is. Now, apart from this beautiful diagram that we've got here, let's look at the mathematical definition first. So these are all sectors. A sector is an area enclosed by two radii and an arc. And that there is not a typo. Radii is the correct plural term for more than one radius. So although I often say radiuses, that's about as correct as me saying mouses, and I'm trying to correct that. So looking over here, I can see this sector is enclosed by these two radii and a minor arc. That makes this a minor sector. The difference between a major sector and a minor sector is that a minor sector is less than half of the circle, while the minor arc is less than half of the circumference. So minor sector, major sector. This sector here is definitely a minor sector. It's definitely less than half the circle. And I hope that you notice that it looks like it could be about a quarter of the circle. Recognizing sectors as being fractions of the circle is really going to help you when you start working out their areas. This last sector down here, I hope you notice, is a smaller fraction of the circle than this one is, because that angle there is definitely smaller than this angle here. This over here is not a sector at all. Yes, it's enclosed by an arc, but the other side is not a radius. It is a chord. So that makes this a segment, not a sector. Those terms are very often confused, so let's try and be careful about that. This last diagram down here may look kind of like a sector, and they sometimes try to trick you about this on exams as well. Here we can clearly see that these two lines cutting through the circle are not radii because they don't reach the center point. So not a sector. Sector areas, again, remember I was talking about them being a fraction of the circle. Well, a semicircle is definitely a fraction of a circle. This is half of a circle. Now, how do I know by looking at it that it's clearly half of a circle? Well, if I plot that center point and I draw the two radii out from the center out to the ends of the arc that encloses that sector, you'll see that I made a straight line, a 180-degree angle. And 180 degrees is half of a full turn, half of 360 degrees. So when we're working out the area of this semicircle, we're going to work out this fraction, the angle over 360, of the full circle area. Now that fraction can obviously be simplified, dividing both top and bottom by 180. That's a half. And by now you should know the formula for the area of a circle is pi r squared. So this is half of pi r squared. Now for any sector area, express this as some fraction of the circle by first working out what angle we see here between the two radii. So I'll plot my center point of the circle and the two radii that go out from the center point to the ends of the arc that encloses this sector. Now, I'm going to label that angle there with the Greek letter theta for now, because I'm not sure what the value is. Theta is often the letter that we use to represent angles in these questions. Now, the area of this sector can be written as the fraction of the angle between the radiuses, radii, over 360 degrees multiplied by the area of the full circle. So a fraction of the full circle. Now in this example, I'm giving you the angle at the center, and I'm giving you the length of the radius, which is 18 centimeters. So to find the area of the sector, I'll set up my formula. It's a fraction of the full area of the circle, and that fraction depends on this angle here at the center, 120. So it's 120 over 360. It's always over 360 until we simplify it, times pi, and the radius squared is 18 squared. Simplifying this fraction, I can see I can easily divide both top and bottom by 120, so that's 1/3. And the 18 squared gave me 324. A fraction times any value we can just multiply that value to the top of the fraction, because 324 pi is the same thing as 324 pi over 1. So I'll do 1 times 324 pi and 3 times 1, which will leave 3 on the bottom. Now I've got a fraction, which is really just a division, so I can do 324 pi divided by 3, which gives me 108 pi centimeters. Now that's my exact answer in terms of pi, approximately 339 centimeters. Next question. This time we're asked to work out the radius, given that the sector has an area of 6 pi centimeters squared. Now, if you're given the sector area, don't think that the sector area formula is not important for you. That's precisely the formula that's going to help you to be turned into an equation that could be rearranged to solve to find r. So starting with the formula, the sector area is equal to some fraction of the full circle. So that's some fraction of pi r squared. And I know the sector area is 6 pi. I know the angle at the center, it's 60. The only thing I won't know in this equation is what r is. But I can rearrange that to get r on its own and find the value of r. First, let me simplify. 60 over 360 can easily be simplified dividing both top and bottom by 60. That's 1/6. Now again, multiplying a fraction by a whole number or whole number term, we just need to multiply the top of the fraction. So that's pi r squared over 6. Now I want to get the r on its own. I see that it's being squared, multiplied by pi, and divided by 6. So let's move the 6 across and multiply it. Then we'll move the pi across and divide by it. Then we'll get rid of the square, and remember the opposite of square is square root. So 36 pi divided by pi will just be 36, and I'm going to square root 36. So r worked out really nicely this time, working with exact values the whole way through. R is exactly 6 centimeters. There was no need for me to actually substitute the value of pi in at the beginning, and as you see, it canceled out really nicely here, so my answer became an exact answer of 6 centimeters. Had I rounded earlier on, I might not have gotten an exact answer of 6 centimeters. It might have been 5 point something or 6 point something. Next example, we're trying to work out the angle theta, given that the area of the sector is 45 pi centimeters squared. Again, I've got the exact area, so let's keep working with pi and see if that cancels down like it did last time. Setting up the formula, sector area is some fraction of pi r squared. I don't know what that angle is, but I do know what the area is. The area is 45 pi, and I know that the radius is 15. Substituting that into the formula, I know that 15 squared is 225. So simplifying this, I get 225 pi multiplied to the top of that fraction, so theta, over 360. Now I want to get theta on its own, but let's first simplify this a bit. So that gives us 5 pi theta over 8. And I want to get theta on its own. Theta is being multiplied by 5 pi and divided by 8. So let's start by multiplying the 8 across, and then dividing the 5 pi across. Now theta is on its own, and we just need to simplify. 360 pi divided by 5 pi. I know the pi's are going to cancel out nicely. Perfect. So that's just going to give us exactly 72 degrees. Theta is 72 degrees. Example 4. Work out the area of this sector. Okay, nothing new. Let's start with the formula. We know the angle at the center, and we know the radius. So some fraction of the area of the circle becomes 54 over 360 of the area of pi r squared. R is 18, pi times 18 squared. Now this can be easily simplified. The fraction simplifies to 3 over 20, and 18 squared becomes 324. Now just going ahead and multiplying that through, 3 over 20 times 324 is 48.6. Now that is still exact. It has not been rounded. Notice my pi is still there. I have not put in the value of pi to keep my answer exact, because this is just part A of the question, and I don't want to round until I get to the end. Part B, Work out the area of this smaller sector. Okay, nothing new again. I know the angle. I know the radii. Let's set up the formula. Some fraction of the area of the full circle. Well, the fraction will be 54 over 360 times the area of the circle, pi times 9 squared. 54 over 360 simplifies down to 3 over 20. And 9 squared is 81. Again, just multiplying that through, just with the 81, leaving the pi as it is as a variable, that gives me 12.15 pi. Again, I don't want to round my answer until I'm finished, and I'm not finished. This is part B. Part C. I've got my two areas for the big sector and the small sector. What about the area of this fan? Notice that this fan shape, and that is a word that we often use in math to describe a shape like this. It's the big sector minus the little sector. And we've just worked out those two areas exactly in terms of pi. So the composite area, or the area of this fan, is the large sector minus the small sector. That's 48.6 pi minus 12.15 pi. Now I'm treating pi like it's a variable here, just as if it were x. So we can group these like terms and say how many pi's do we have altogether? 48.6 minus 12.15, that's 36.45 pi. So there's our exact answer for the composite area. Let's go on to some practice. Now here we're just talking about sector areas, but in some of these questions I am giving you the area of the sector, and I'm asking you to work out the angle or the radius. This first one should be pretty straightforward. I've given you the radius and the angle, and you're just using this formula to find the sector. But remember, we are always using this formula, either to find the sector area or when we are given the sector area. So hit pause now and give it a go. The answers will come up in just a moment. Okay, I hope you hit pause. Here come your answers. Now note that my answers are exact. Because I gave you the sectors in terms of pi, those pi's have canceled out nicely to give you nice exact answers for both the radius and the angle. Please let me know if you had any problems or if I've made any mistakes here, and keep practicing.